This video will be looking at a first order non-homogeneous differential equation. Now you may have seen a simpler version in maths or maybe AS further maths where essentially you have like t and y and you've got to rearrange to get the t's on one side, the other variable on the other side, and then you've got to integrate both sides. This is a slightly different version. And just to quickly explain exactly what these terms mean here. So the first order basically tells us we're dealing with the first derivative of a variable. So for example, if we had y and also dy by dx. In this example, we've got p and dp by dt. The non-homogeneous part tells us that the equation is not equal to 0. So here it's equal to obviously t to the power of half, open brackets, 1 plus t, close brackets. And then the differential equation, obviously how we're dealing with p, dp by dt, and t. Now the very general principle of a type of question like this, where you have a p plus something times a dp by dt, the sort of style to approach this is you want to get it in the form which allows us to use product rule. So product rule is obviously if we took the derivative of x times y, that is equal to the derivative of x times y plus x times the derivative of y. So that is the general principle. We want to rearrange it in this form. And you can just read a bit of context here. So here we're dealing with bacteria and how they grow. Bacteria p in thousands, which is a crucial thing which I would highly recommend that you underline. And then it tells us the differential equation. Another very important piece of information, t is the time in hours. So just be very, very careful about that. And then obviously it tells us initially there are 5,000. We're going to use this piece of information a bit later on. So there's sort of two main approaches, but with this style of question, there is a methodical way you can look at this type of question though. And the first bit is sort of by observing if we can express it in this form. Because the principle is once we get it in this form, we'll be able to integrate, and then the derivative and the integral cancel out, and then we have x times y, for example here, and then if we were to integrate both sides, obviously we'd have the integral of the right hand side as well. So we're sort of looking to see if we can get it in this form. Now if I just imagine that the y in this little example here is the p and the x is the t, you can see here how, to be honest, you can actually already leave it in the form, because you can have, so y times x derivative, so we can imagine there's an x derivative here, or in this example a 1 plus t derivative, because 1 plus t differentiates to just 1, right? So I'll just write that a bit clearer, but essentially you should always just look to observe first of all without doing the method which I'm about to show you. Just look and observe if you can sort of leave it in this form, or get it in this form straight away. Sometimes it'll be easy, most of the time it won't. Most of the time you will need to do a bit of a complicated method. Not too complicated, but a method that I will show you in a second. So you can see here how we can write it like this. 1 plus t derivative times p, because obviously this is 1, so it's just 1 times p, and then it's equal to t to the half 1 plus t. And then from there you can express it obviously with product rule, so it would essentially be the whole derivative of 1 plus t, being one term like the x for example, times p, right, is equal to t to the half 1 plus t. And then obviously, you know, if we leave this undifferentiated, the 1 plus t undifferentiated, it'll be 1 plus t, differentiate p, so dp by dt, plus, because it's product rule, then we differentiate the 1 plus t, so the derivative of that times p, which is obviously here in the step above. Now, like I said before, how most of the time this method won't be viable, because usually it'll be a complicated thing and you can't just observe it straight away, but sometimes it will be. We got lucky in this question, but I will show you the actual way if it didn't have a sort of nice simplification like in this question here. So the first step you should always do is ensure that there is nothing in front of the derivative, so dp by dt. This first step is so crucial because if it doesn't work out nicely, you can't get your differential equation to work out at all. So you have to just have dp by dt on its own. So here obviously we can divide everything by 1 plus t. So first step, dp by dt plus, and then 1 over 1 plus t, which is what we're dividing by, times p is equal to t to the half, and then it'll be 1 plus t divided by 1 plus t, so we'll just leave it like that. Now we're going to be introduced to something called the integration factor. The integration factor is basically, once we do the method, we'll get a number, and that is what we do times this equation that we first formed, but at the start of our workings out, because then that's going to tell us, it's going to give us a form that we can then easily put it in this product rule form. So the way to do the integration factor, so I'm just going to write if here, it's always e to the power of the integral of whatever's in front of the p, or if it was y, for example, i.e. so like whatever, so the not derivative part of the differential equation, but obviously it's not t because we have dp by dt here. So dp by dt, we ignore that, we look at the p, and whatever's in front of it, it'll be the integral of that. So the integral of 1 over 1 plus t, you can write by dt, but it's not necessary. Now, you should know by your integration rules that this integrates to e to the ln of 1 plus t. And there's no chain rule here because 1 plus t will just differentiate to 1. So, we don't need a plus c either when we're doing the integration factor. It will just confuse everything and make it look a bit messy. But here, because we have e to the power of ln of something, the e and the ln can cancel out very nicely. So as our integration factor, we get 1 plus t. Now you can see how when we times this original equation by 1 plus t, it'll get exactly what was here originally. But like I said before, how most of the time it won't be simple. It would be something else 90% of the time. And also, even if it was simple and you did it like this, you'd get the marks, because the mark scheme still assumes that you do it via the integration factor method. But as we did know that it would work out nicely, we get 1 plus t times dp by dt, and then we have plus, and then the 1 over 1 plus t times 1 plus t, so it's just 1 times p is equal to t to the half times the 1 plus t, which is, like I said, exactly what we have here. Now, like I showed you here, how it's easy to just sort of put it into this form, just to sort of show you the way I'd do it. I'd always look at the one with dp by dt, and I just replace it by p. Very easy. So I just write like this, square brackets, and then the 1 plus t times p, and it's the derivative of that. Like how you would do product rule, if you did, you would get the thing above. And then that bit is equal to t to the half, 1 plus t. Now, the way we get rid of the derivative is we actually integrate both sides. So, I'll do it in another color, but essentially if we do the integral like this, what would happen is the integral and the derivative cancel out. So, we would get 1 plus t times p is equal to the integral of this with respect to t. The thing that you got to do here now is obviously integrate one side and don't forget the plus c. You could have done the plus c on this side. I would recommend on the left hand side. I would recommend you do it on the right hand side, because you're integrating with respect to t, and like if you had the plus c on the right hand side, it's easy to just sort of like in this example, we'd have an equation here, and it's so easy to just divide both sides by 1 plus t, so we just get p equals and then an equation. So I would recommend you do the plus c on the right hand side. And obviously don't do it on both hand sides because it would cancel out. Don't do like plus c and plus c. Just do it in one side, because remember they're constant, so we don't know what they are. so we can't assume that they're just going to cancel out very nicely. So now we've got to integrate this, and initially you might be thinking, what complicated methods of integration, but the ones who are observant can realize that we can just times it out and integrate it in the very, very simple method that we used to do back in GCSE. So t to the half plus t to the 3 over 2. And we can obviously add 1 to the power and then divide that new number, and then plus c. So 1 plus t times p is equal to the half plus 1 is 3 over 2. 1 divided by 3 over 2, 2 over 3. So 2 over 3 t to the 3 over 2. Do the same, plus 5 over 2, 1 divided by 5 over 2, 2 over 5. Very simple. And then t to the 5 over 2, obviously don't forget to add 1 to the power, plus c. Now if we actually look at what the question's asking, you should always do this step, by the way, and then you might go in a few different paths. Sometimes it'll ask you just for the general differential equation, or sometimes, like in this example, it'll ask you to actually determine the number of bacteria 8 hours after the start. But like I said, how we have to, if we wanted an actual number, we need to get rid of the plus c. Now how do we do that? Because it tells us initially there are 5,000 bacteria. So what does that mean? And this I also would recommend be very careful, because p is not the number of bacteria, it's the number of thousands of bacteria. So actually, what we should write is that when t equals 0, p is equal to 5, not 5,000. This will throw a lot of people off, so just be very, very careful. Now obviously the 1 plus 0 will just be 1 times p, 5, so we just have 5 is equal to 0 times all of these will be 0, and then the c will be there, so 5 equals c. So very simply we just solved our equation as 1 plus t times p equals all of this plus 5. Now actually what I'm going to do is I'm just going to have this whole thing, I'm going to divide it all by 1 plus t basically. Just going to do it in one step just because it saves time. I recommend you always write it out like this every time. Don't always skip steps unless you're absolutely sure you know what you're doing. So here it's quite a big fraction because you're going to have 2 over 3 t to the 3 over 2 plus 2 over 5 t to the 5 over 2 plus 5. All of that is over 1 plus t. Now you could have 1 plus t for each of the individual components, but I'm going to explain right now why not. And the reason is because you're going to have to plug this thing in the calculator, and it will be such a shame right now for you to lose that final mark by just plugging it incorrectly into the calculator. So the question asks 8 hours after the start of the study, and remember that t is the time in hours. So when t equals 8, what is p? So plug p into all of this, and then once you do that, you should get as your answer 10.2769 ... So that's our final answer, right? Absolutely not. So I'll just write a few more decimal places before explaining why not. Because if you remember before, p is the number in thousands. So it's 10.276 thousand bacteria. And the question is asking for the number of bacteria, not the number of thousands. So actually, you have to times this number by 1,000. And just to say it quickly, 10,276.96, whatever. I personally would just round this to 3SF. So I would write 10,300 bacteria. And then if you want, you could write 3SF. Obviously, the more significant figures you round it to, the more accurate your number will be. Usually 3SF. Now part B of the question says, find, according to the model, the rate of change of the number of bacteria 4 hours after the start of the study. So what are we doing here? Well, the question says the rate of change. So immediately we're thinking differentiate. We want dp by dt. So how you see in part A we had p in this form here. Now what's actually going to happen is we're going to have to differentiate this. And we're going to get dp by dt equals some, well, annoying fraction, as you can see from this p. And then we're going to have to plug in t equals 4, because it's 4 hours after the start. And we're going to get a value. And then for 4 marks, that should be our number. Part B is dp by dt. And by the way, for the people thinking that you could just rearrange this, you can't, because you have p as well as t. So this is why you need to only differentiate the part you got here, where it's just p in terms of t. So the quotient rule, if we had u over v, we would have the derivative of u times v minus u times the derivative of v all over v squared. So to differentiate the numerator, 2 over 3 times 3 over 2 is just 1, and then you minus 1 from the power, so it's t to the half plus 2 over 5 times 5 over 2, 1, minus 1 from the power, t to the 3 over 2, plus 5 differentiates with 0. So we're going to have this times 1 plus t, because that's the denominator. Then we're going to minus all of the numerator times the derivative of the denominator. But obviously the derivative of 1 plus t is just 1, so it's basically just whatever's in the numerator, which is 2 over 3 t to the 3 over 2 plus 2 over 5 t to the 5 over 2 plus 5 all over 1 plus t squared. Now, would I recommend you times this out? No, because the questions are asking for the rate when you plug t equals 4, so you can simply just plug t equals 4 into this equation. Although it will look a bit cleaner, you might be less likely to mess up in the stage where you're just plugging it into the numbers, but you're more likely to mess it up in the stage of calculating it if you end up timesing everything and then collecting like terms and then rearranging. And actually what I should have done, mistake on my end, is minus all of this. So this is what I mean by you could easily make a mistake if you're not careful. And it said 4 hours after the start of the study, so when t equals 4, dp by dt, what is it? Well, plug t equals 4. And by the way, you don't have to show that you've plugged it in, so you don't have to write 4 to the power of half plus 4 to the power of 3 over 2. You don't have to, but you can, because to be honest, this sort of question does seem a bit generous for 4 marks, so if you want to sort of show that you know exactly what's going on, you could. But this step, when t equals 4, what is dp over dt, that's more than enough to show them that you know what's going on. But from here, your number should be 403 over 375. That's the final answer, right? Wrong. Just like how p is the number of thousands of bacteria, this number here is the rate of change for thousands of bacteria. And the question is asking for the rate of change for the number of bacteria, not the rate of change for the thousands of bacteria. So, once again, be very, very careful. A lot of people will slip up here, just like how a lot of people will slip up at the end where they forget to times their p by 1,000. So simply times this number by 1,000, and you get the rate of change is 1074.66 ... So I personally would write rate of change and then 1,000, and I personally would, although I said 3SF, this one I would do 1075 just because it looks cleaner. 1075 bacteria per hour, and you don't need to write bacteria per hour, but just to show you clearly what's going on. So another one of my major tips I would say is that always look for a cheeky 1 marker at the end, because just like here, there is a very cheeky 1 marker that's so easy to forget, but it's so easy to get that mark if you do it right. And although these sort of questions can be a bit time pressuring and you might want to move on quickly, just scan. Have I got an answer for part A? Have I got an answer for part B? Have I got an answer for part C? Now, I'm not going to write this one down, but I'm just going to tell you. Usually with these limitation questions, there's usually 2 very simple ones. It'll be one or the other. Now, the first one is usually that for large values of time, for example, the number approaches infinity. So here, if we look here, p, we have the power of t, 5 over 2 is the highest power, and for the denominator, t to the 1. So the numerator will increase at a faster rate than the denominator increases. So t will actually approach, as t approaches infinity, p approaches infinity. You could write just and then you just say which is unrealistic, for example, or just say if you leave it for long enough, the model says that the number of bacteria will be an infinitely high number, which is unrealistic. So that is one of the assumptions, and that is the right assumption to do for this question. But the second one, which I told you there's usually 2, if it's not that one, it could be this one, and that this one is basically that for large values of t, you could have a negative population, for example, which doesn't make sense. So usually one or the other, either for large values of t, it approaches infinity, large values of t, it approaches a negative number or approaches 0, or just look at the context of the question, and you always have to write it in the context, because that's how you get the marks for the question. Although it's only 1 mark, you have to, convince them that you know exactly what you're talking about, especially because it's usually one of the 2 choices. It might be like a limitation as well if it's like a mechanism, for example, and might not account for something, but as safety, always look for those 2 first. And if it's not one of those, it might be something else which is more specific to the context of the question. And that is pretty much how you solve this style of first order non-homogeneous differential equation. Thank you for listening in.